ladies and gentlemen, welcome. Thank you for coming to the Waltham Museum for this special event. Waltham Museum is a non-profit, all volunteer-run museum incorporated in 1971, and we're open for visits, for guests, and for volunteers if you'd like to get more involved in the history of Waltham. A couple of amenities. The restrooms are just down that corridor, and across the hallway is refreshments, and you're welcome to make your use of them. So we're pleased to bring Will Benjamin, who has a fascinating journey in the career of watchmaking, watch building, and repairing. Excellent. And Will's going to share that with us. So please welcome Will Benjamin.
Thank you, guys. So, as Tom mentioned, I have a very weird journey into watchmaking. So, basically in COVID, I started to watch YouTube videos and started to fall in love with watches. And I tried to find jobs or like around the watch community, trying to get my hands onto watches and stuff like that. And so I joined some associations, and then I eventually worked for the watchmaker in Stoneham for 2 years. And then I went over the summer to Renaissance for 6 weeks in Belgium, and I worked there repairing, building, and prototyping watches.
Sorry, can everyone hear Will, or should we get the speaker? Okay. Sorry.
Okay, so basically, in doing that, I've learned a lot about watches. So I'm here to tell you about the history and the inner workings of watches. So time itself has always been important. From early hunter and gatherers relying on it to figure out when they can go hunt a mammoth or do whatever they need to do. And it was always relying on the sun and the moon cycle, but never really like measured or timed. So it wasn't really like, there was no system in place to make sure what time it was. Until after that the sundial came into place. But it was always important. You always needed to know what time it was to figure out when you could do certain things. Because our days always relied on time, and what we were able to do is dictated by the time. So that's why later on, the Egyptians invented the sundial, which was invented in the 1500 BC. And this basically was the first way to actually measure time. And it was done by using a gnomon, which is the piece right here, or just really any sort of rectangular or stick that you could put in place at a certain angle depending on the latitude, because the latitude of the Earth dictates, because you need to be in line with the pole. So if you were on the North Pole, your angle of your gnomon will be 90 degrees. But wherever you are besides the North Pole, you have to do some calculations to figure out what the angle needs to be. And so these were used to basically figure out this cycle in the day. So it's technically 24 hours, but because the sun goes down after 12, you can't really tell what happens. But it's set up to be 12 hours in a semicircle. And you can then figure out what time it is through the shadow of the gnomon, and it'll give you increments. You can figure out like a half an hour, stuff like that. And these were used for a while by the Romans, Greeks, all over the world. And there's actually a funny story where basically there was a fight, and the Romans ended up stealing a sundial, and they brought it home and put it in the forum, and they didn't realize what I just said about the latitude, where it needs to be specific to the area, and that caused their sundial to be inaccurate for use. But they kept using it, trying to figure out what to do during the day, so they were always off time. They were never doing the right thing. And that, as I said, was important because you need to know what time it is. Back then it was a little less important, but as things go on, it gets more and more important. So sundials and time-keeping measures have always been advancing to try and cope with that necessary innovation. And this is where the Industrial Revolution comes in, which is like the 1800s or late 1700s. And here basically is when time was a necessity, because the invention of trains and steam engines and factory workers basically made it a necessity to have accurate time and consistent access to it. Because everything was faster. Everything was on a schedule. All the trains were on a schedule. It doesn't matter if you were supplying and shipping things through the trains, or if you were just getting on that train to go work in the factory in the morning, or going to meet with your boss or do whatever you were doing. So they were necessary. And originally they were just put in walls, like that clock there, or put in the streets, like this one here. And you couldn't really like bring them with you because they were too bulky and you can't really bring a wall clock with you. So they weren't really viable for the future because as things kept getting faster, like with the Romans and that cycle powers, like the sundial needs to be further advanced, we need to further advance these. Because the trains started getting faster and you had more ways to get around, more schedules, like we all do now. So it was necessary to advance them. And that's when we got the pocket watch, which was originally built for train conductors and things of that nature because they needed to be able to tell what time it was when they were driving the train, figuring out what time the train needs to leave the station, be at the next station, if they were on time, if they were late, if they were early, figure out everything. And so they originally were built for that, and you would keep them in your pocket, and they would be vertical. And that is a key factor which I'll talk about later, where like the verticality of them was not very good for them. But these were very important because they weren't just used for trains and used for things like that. They were also became a symbol of status because pocket watches had a chain that would go from your waistcoat down to the pocket, the watch in your pocket. And that became a symbol of status if you could have that, and if it could be gold plated, silver plated, whatever it may be. If it was shiny and pretty, it was showing your status. And even more on the status topic, they became a part where you could basically manipulate your employees, because employers would restrict the access of clocks and pocket watches of their employees and basically make it so that they could lengthen the workday or get rid of a lunch break or do things like that because they couldn't tell what time it was. So it was, these pocket watches didn't just change how people did their daily lives, like the clocks and the sundials. That also changed how the societies were like managed and built, because there was always status when it came to pocket watches. It doesn't matter whether it was because yours had the gold plated and 17 jewels, or they had diamond jewels instead of sapphire jewels, or if it was just because your employer didn't allow you to have them. There was always a status built into them, and that's a key factor when you're talking about pocket watches because it was the first step where like luxury goods were also kind of a necessary good, and it became this weird status fight for reliability. But men were pocket watches. Women were not allowed to because they couldn't wear a chain on their dress. It wasn't proper. So women wanted access to the time like everyone else because it was necessary and it was helpful and it dictated their lives, so everyone needed it. So in 1810, Abraham Louis Breguet built a wristwatch for the Queen of Naples, and it was the first wristwatch, which was a big deal because it wasn't just making a wristwatch a new thing. It was also giving women access to time and giving them the freedom that they could have their own access to time and not be like shackled to their man with their pocket watch. But it also changed how wristwatches were viewed by everyone because at the time, men only wore pendants or pocket watches, and pendants were either just some sort of jewelry that had a chain with either a photo or just some sort of design at the end, decorative piece, or a pocket watch. And because these were originally produced for women, they were never seen as men's accessories or jewelry. So no man really wanted to wear them when they became more popular. And that's where World War I came in, when it eventually pushed it to men. But it was a hard shift because they had their pocket watches. They didn't want to wear this womanly jewelry. So it was this weird shift, but it was also a very important one because it also moved the industry, making watches smaller and the mechanism smaller because it was necessary to make a women's watch because they weren't just like a pocket watch strapped to your wrist. They were very like eccentric, beautiful bracelets that would then have a watch hidden inside them. It wasn't a watch with a bracelet, it was more just a bracelet with a watch. So it really pushed watchmakers to make very small and accurate and delicate watches, which allowed for future advancements to come later. And so one of the main things that watches run off of, and the basic part of every watch, is the escape. So as I said before, pocket watches were not very good because they were always in the vertical position. And nowadays, that's not really that big of an issue because our manufacturing and our ability to like perfectly cut a piece of metal is much more inept than back then, much more accurate than back then. So, but then it was, if you had a little bit of extra metal or a little bit cut off of the balance wheel or anything like that, any sort of issue, these would not run very well. And that was common back then. So if there was gravity, the hairspring right here, because it's so small and so frail, it would be pulled down by gravity and it would be disformed and not rotate at the same perfect rate that it needs to. And so this became an issue and it eventually was solved, but it was a very expensive solution and wasn't really manufactured and pushed to everyone. But now we just have better manufacturing so we can build them more efficiently. Like for example, the hairspring is sometimes made of silicon instead of steel or any sort of other metal. But this system, I can pass around this pocket watch right here. If you can see, right, there is a little balance in there and you can push it around. It's a little loose from the hairspring, so it's not as free, or not as like locked in place as normal, but that is basically what runs the entire watch. So as you can see here, you have a wheel, which is called the escape wheel, you have the pallet fork, balance wheel, and then hairspring. And the lubrication of these parts is very important because, so basically there's 3 joules in this system. There's 2 on the pallet fork and there's 1 roller joule on the bottom of the balance wheel. And that joule right there doesn't actually get lubricated, but the 2 on the pallet fork are very important because they're constantly moving, constantly being affected by friction. And we want to mitigate that as much as possible because the rate at which this moves is very, very important. Because if you're off by even like a millisecond, your watch will be off and lose time and not run perfectly. So you have to make sure the lubrication is perfect and not going to leak out and not be on top of the gear and then eventually wick away at the lubrication on the joule. So you have to be very careful. And because also if you have too much lubrication, then it'll cause too much friction. And then if you have too little, it's obviously going to just scratch and not run well.
Yeah. So when you say joules or an 18 joule watch, in this example, say those purple things, that's an actual piece of amethyst or something?
So back like when pocket watches were really made, it was mostly just actual jewels, so like sapphires and then sometimes even diamonds, which didn't really have a difference, but it's more just for looks that it was a diamond. But now we use a lot of lab-grown diamonds, so lab-grown sapphires, so they're all synthetic. Because it's more efficient, cheaper, but it's technically an actual jewel if you like brought an actual watch in, but it's more synthetic now.
And you talked about the watches running differently, vertical versus horizontal. Would you also either gain or lose time, say during the summer versus the winter?
Now it's marginal. I don't know.
Well, back then.
I don't know if it would affect it that much. I don't think so, because it wouldn't expand that much. So you're saying with the heat of the summer and the yeah. The oil might be affected, but it's very unlikely because it's like the margins are so small, so you would assume that it would affect it, but it's also moving so much that it's not going to be really affected by it, if that makes sense.
Can I ask about jewels, since you brought it up? Why do they use jewels instead of making it all out of metal?
I'm going to get to that in like the next thing, but so I'll answer that. But what I was going to say about, you asked like how does the timing work? So basically, when it's not running perfectly, or if it's at a different angle or a different position, the hairspring won't run perfectly because it's distorted and it's not going to get that perfect circular oscillation. So you have to make sure it's perfectly timed. So you have to make sure that the roller jewel is rotating at the perfect degrees, so the amplitude has to be perfect. So it's either between like 270 and then 340 are your minimum and maximum. So you want to be between those. And then you want to make sure that the watch is running a little bit fast, because it's naturally going to lose time as the power runs out, because it's going to naturally slow down and not run as fast. So if you have it starting to run fast, then it'll eventually even out, and you'll basically be running like even by the end of the day. So it's very important to make sure that that's how the watch is running. And so, because if your amplitude's too high or too low, it'll either go too far past and then hit the pallet fork twice in one rotation, and then it'll like double tick, you could say, or will only hit it once or not hit it at all, and then it won't tick at all. So you need to make sure that everything in this system is running perfectly, or else your watch won't be running accurately the entire time. And then so to your question about jewels, so basically jewels are used because the bearings, like if you want to make a ball bearing this size, it's impossible. So to make sure the gear isn't like scratching against the other metal on the bridge, you have to have a jewel, which makes the surface frictionless, because it's the highest metal or highest level in the most hardness scale, so it's very hard and it won't scratch. And it takes really well to lubrication. And so basically, they're just a better way to make sure the gears won't like scratch. Because also, if it's running for long enough, even if like you have a jewel, sometimes you can see metal particles being produced from the rotation of the gear, and that can stop the watch and eat away at the wall of the bridge or the actual pinion itself from the gear. So it's very important to have some sort of barrier between them. So that's why we use jewels. And so there's like two main types really. So there's these, which are just like your general jewel, which you'll just put in any sort of pinion. And these you can see in, if you pass around this thing right here, you can see the jewels are right there, on the top of the bridge. So on top of the bridge, where the gears go in, there's jewels. On every, most pinions will have a jewel, not all, because some don't need them because they're not rotating fast enough, or they're rotating too fast. But what you'll do is you then lubricate it. So this one right here, for example, you want to fill that well, so the jewel makes a little well around the pinion, which you then fill and make sure that it's not too much, because then it'll wick away and slowly pull out of the well and pull away from the pinion, because it'll naturally want to go to the other place instead of the well. So it'll be like a ball over here and it'll pull that way. And you don't want too little, obviously, because then you're not lubricating the gear. And then there's also these right here, which are called cap jewels. So this right here is called the kith. There's different kith systems, which basically just hold the cap jewel together. And these are used on the balance and the top and bottom of the balance to make sure that is running perfectly. Because like I said, if there's any sort of friction or any sort of thing stopping it, it's not going to run perfectly well, and you need that to be running well. So these are very difficult to lubricate, because you have to lubricate this, so the cap itself, you have to then flip over and put a perfect amount of oil on, and then put it together with this piece right here. And then the pinion will then go through like all the way through here and then touch this. So it'll be pushing against that, and you want to make sure that the oil isn't too much where it's hitting the edges, because then, like I said before, it'll wick away slowly and seep out, and it won't stay where it's meant to stay. So you want to have enough where it's just in the middle, but not seeping out, and you don't want too little where it's not holding and hitting all of the pinion. So that's the difficulty with the cap jewels, and then those, yeah. If anyone has any questions, just ask me.
Well, how do they keep it lubricated? Is that what leads to servicing eventually? Or?
Yeah, so normally that's why you'll have like a service agreement for it, 5 years, you'll have to add more oil, and because also you have to like clean the watch. But the oil, like sometimes it'll get hard, so like that's basically the main reason you need a service. But if you have a watch for like a year, the oil will stay perfectly how you put it the first time. It might like move around a little, so like when you first lubricate a jewel, it'll seep in a little bit, but then as it runs more, because the pinion will move more, it'll seep in through the sides and hit and coat the sides of the pinion. So it'll look like there's less oil, but over time it won't actually go away for that long. Like it takes longer for it to actually fully go away.
Yeah, thanks.
So this is the basic watch movement that is basically in every mechanical watch. So you have the barrel, you have the escapement like we talked about, and then you have the drivetrain. So the barrel, it has the hairspring inside of it, mainspring inside of it, which has changed a lot throughout the years because originally it was just a normal spring, very like simple, just any day spring. And that was breaking a lot because if you wind a watch too much, it'll then try and break itself basically. So you need to make sure that there's some sort of system in place where the watch won't break, especially with more automatic watches nowadays. So because those are constantly being wound by a rotor with the movement of your arm. So if it's constantly being wound, it'll eventually break, and having a spring pop out and break at you is not a fun experience. So there's been some advancements where it has one side basically where it's a coil, and then it has a tail, and that tail splits into two, and that tail basically allows for it to slip along the wall and not get stuck. So then instead of just getting stuck and trying to keep winding, it'll slip, and then once it's fully wound, so it'll just slip along as it goes, as it's being wound extra, instead of breaking. And there's little like lodges or notches in the side of the wall, so it can lock in, so it's not just unwinding the entire time, so it just stays there. So that's basically what the barrel is like. And if you want to just look at the piece of the barrel, you can see this is just the watch with just the barrel in there, so that's the barrel right there. And then you have the drivetrain, which I will get into later, but basically this is what's stopping, or connecting the barrel and the escapement, because it looks like the escape wheel is being pushed by the balance wheel or by the pallet fork, but it's actually being locked and then unlocked, locked, unlocked, locked, and unlocked as it's moving back and forth, because this is just connected to the mainspring and it's all trying to be constantly driven, so it's constantly just trying to spin as fast as it possibly can, but this is stopping it, so it's just keeping the power and slowly letting it out at certain intervals. So you're not just getting like a whiz of just like the constant power going out. And if you go to the next slide, you'll see, so this is the drivetrain. As you can see, it's connected to both the escapement and the barrel. And there's 4 wheels, so this one is kind of in the drivetrain, but it's more in the escapement, and that's the escape wheel. And then there's the second wheel, which spins once per minute. And then there's the third wheel, and then there's the intermediate wheel. The third wheel spins every 3 minutes, just one full rotation. And it's kind of a weird wheel because you could argue it's the second wheel, but then, because if you look from this direction, but then also when I was working at Renaissance, they call it the small middle wheel, but in French. And I'm not going to try and say that because they always made fun of me whenever I tried to pronounce it. But basically that one isn't as important as these two, because this one is connected directly to the barrel. So there's the top wheel, which is connected to the third wheel, which is just like the bigger one, which can move it to the drivetrain. But the bottom there's 2 like gears kind of on the pinion, and these basically take the power from the like teeth here, so it'll latch into those. So then as that tries to spin and like spin loose in its spring, it'll send the power through to the drivetrain, and then this is locking it in place, obviously, but like I said before. And then, so as you can see here, it's kind of hard to see, but there's a hand right there. So that's, because the second wheel rotates once per minute, you actually attach the second hand directly to the second wheel pinion. It goes all the way through to the top of the watch. And so that's basically why like these two are the most important. But then if your watch isn't running that well, you can kind of tell which wheel is having an issue. Because as watchmakers, we listen to the watch with microphones, because we can't really tell, like if we're trying to adjust the hairspring, we can't really tell how many degrees the thing's spinning just by listening to it or looking at it. So we have to use microphone. And so what you can do is you can see if there's an irregularity, you can see how often the irregularity happens. And basically, if that is happening once per minute or like every minute, then you'll know it's the second wheel's having an issue. If it's happening every 3 minutes, then you'll know it's the third wheel. And then if it's happening, it's very unlikely for it to be the intermediate wheel, because those pinions are actually very large. So it slots in very well in most bridges, and that's because the issue that you're looking for is if the jewels are not perfectly aligned and perfectly spaced, so the wheels are having a little bit too much leeway and ability to move. So, because you have to adjust the jewels sometimes if it's like you're using a different bridge from a different watch or something like that. That's why it's hard to do that. You have to make sure that they're perfectly spaced so then the wheel can move a little bit, so it's not being held in place, but it's also able to, it's not able to just like jump around. So the drivetrain is very important because he takes all the power in and he moves it around, but it's kind of less interesting than the escapement. Yeah. And then, as I said before, World War I was basically when wristwatches moved from women's wrists to men's. And that was because it was mandatory, a part of the mandatory uniform for men in the World War I. So all across the world, countries started partnering with watchmakers to basically supply the military. So like in the US, Hamilton was a watch producer that we partnered with. They produced a lot of our watches. Waltham also produced a lot of our watches for the soldiers. And so basically, originally, before we had connected with the producers, a lot of soldiers would just take their pocket watch and just strap it to their wrist. And that's called a wristlet. It wasn't really the greatest design because it was this big, bulky pocket watch that was on your wrist, and it wasn't really like fitting well, and you're trying to fight, and you got this big thing on your wrist. It didn't really work. So they moved towards trench watches, which had a lot of iterations, and they basically changed a lot because you're going from a delicate jewelry watch to a watch that's meant to sustain war and be able to like be shot at, well, not actually just take the bullet, but deal with the shrapnel and everything that comes with war. So it's not really the same thing as like a diamond bracelet going from that to the trenches of World War I. So the watch had to change a lot. And one of the things that changed was the dial. Because you're mostly in a trench, you don't have lights or you don't have candles, you're not in a house. So they had to use radium, which is a radioactive material. And what they basically did was they had women in factories, they would lick the tip of a paintbrush, and then they would apply the radium to the dial, which, yes, it does not sound safe because it is not. So that was one way that they changed the watches and brought them to World War I. And that was actually, the radium application happened a lot in Waltham. But, so that was one thing that changed. And the crystal itself, so the glass on the front of it changed a lot too, because it wasn't, like originally glass was actually used and that wasn't strong enough to really sustain much. So they started, like some companies put a metal cage around it, and that worked for some times, but then the issue was you have a metal cage around your watch, so if you're in a battle and you need to see when the artillery is going to bring in like the bombs, you need to figure out what time it is really quickly. You can't look and see a cage and figure out, oh, is that the minute hand, is that the cage, I don't know what's going on. So it was very important to be able to see the watch, so that really didn't go so well. So then they moved to sapphire crystals, which is what is used now, because it's like the sapphire and the jewels, it's a very hard thing on the lowest hardness scale. So it's very difficult to scratch, very difficult to break, and it works really well in this situation. And if you go to the next slide. They were basically very important because it allowed them to coordinate with planes, because World War I brought like aircrafts and the fighting in planes and connecting the infantry with the soldiers in the air. So they needed some way to connect them. And what they did is they just did it through timing, so they would know when a bomb would be dropped or when there would be an airstrike or anything of that nature. So they would basically synchronize the two and coordinate the attacks together. So they became very important. Every soldier would use them every day, and they would know when their friend is going to drop a bomb, or know when they need to wake up and go like watch the wall or whatever they were doing in the war. And so it was it became very important in every man's life that was at war. So it became very normal for them to want them when they came back to the normal world after war. So this right here is actually a Waltham advertisement for watches after the war and like during the war. So it was basically saying like if he fights, he's gonna want a watch, and then why not get him one when he comes home? So people would start to buy watches and bring them home and take their watches from war and use them in day-to-day life. So that's kind of when the shift happened, when everyone came home from war. Everyone started to wear them on their daily life. And it didn't really change from there. So basically the 1930s was when wristwatches became a big part of men's accessories and fashion, and moved from women's wrists to men's. And then, so that was 1930s, and then 1970s was when the quartz crisis happened, which wasn't really a crisis, because it was only a crisis for the Swiss watchmakers that lost business. Everyone else gained cheaper watches and access to more accurate and cheaper watches. So you could argue it's not really a crisis, but basically in 1970s, Seiko released the quartz movement, which basically uses the quartz crystal right here, and it sends an electric current through it, and they figure out that that oscillates at a perfect frequency of 32,768 times per second. Don't know how they got that number, but it was basically meant to replicate what a balance wheel does, because you can't really do that without using a mechanical mechanism at the time, so then they found that this would work. And then everything else was kind of similar to a normal watch, so they had the gear train or drive train, and then they would just run the power through a battery, send that through the current of the quartz crystal, and that would just send power to the hands on the top of the watch. And it caused a lot of issues in the market because all these companies went bankrupt basically, and to help that, the Swatch Group was created, and a lot of other big groups were created. So what they would do is basically they would buy out these like rich businessmen would buy out these companies, and to allow them to sustain their business and not just go bankrupt and die, because they had a lot of historical value and a lot of people just loved mechanical watches. They didn't want them to die. So one of the main groups is the Swatch Group. So a lot of companies were bought into the Swatch Group. And the reason why they were able to keep some money and keep income was because of Swatch itself, because they started to create their own Swiss watch, quartz watches. And because they did that, these companies gained some sort of income. But they still were not in a great position because they were mostly bankrupt. But it allowed them to stay alive, and then eventually once the quartz crisis kind of ended and people started to like enjoy mechanical watches again, they had a system where they could basically sustain themselves. But the issue with big conglomerations like these and groups like these is it kind of takes away from the creativity. So for like Renaissance, that's an independent watch company, so they're not connected to any sort of big group. And because they're not, they're able to do whatever they want. They're able to make any sort of watch, whatever they think is cool, whatever they think is new and trendy, they can make that. But in the case of a big watch group, you have to you're dictated by the owner of the group. So so for example, Swatch Group owns Tang and Breitling. If they tell Breitling they want only chronographs from Breitling, that's what Breitling has to make. So they can prioritize certain companies to make certain things, and then they can tell Tag to make dive watches. So it kind of dictates what the companies are able to do, but it also keeps them in a reliable system. So like, if a company wasn't doing well making, I don't know, like chronographs before, and then they're bought out by the Swatch Group, then they might start making dive watches because that's what this watch group wants from them, and they start doing better because that's what the market wants. But they're not able to be as creative and be really what they were before they were bought out. So it changes how they're viewed and how they basically work in like the design team. But in the end of the day, it helps the company stay alive and helps them produce more watches. And as I said, chronographs. So basically, these are some complications that I'm going to talk about. But a complication, so as I said before, what I spoke about was a basic watch movement. So basically, every watch has some like version of a balance wheel, an escape wheel, a pallet fork, a drivetrain, and then a barrel and a mainspring. Because that's what runs every basic watch. So then a complication is basically taking additional functionality and adding it on top of that watch, whether that be an automatic movement, which is kind of less of a complication now because it's become so popular, which basically just winds your watch throughout the day from the movement of your arm. But things like that are considered complications because it's complicating the normal watch movement and making it more in depth. But, so for example, a chronograph, which was originally invented for horse racing, is one of the most common watch complications. So that's basically a stopwatch. It's a glorified name for a stopwatch. But basically what it does is you have two pushers, and these will basically push the system and engage it, and the gears will lock into the drivetrain and give it power. And it'll start the chronograph seconds hand, which is the big one in this case. But normally people think that that's their actual seconds hand, but they will normally have a running seconds hand, which is one of the subdials. But for a chronograph, you basically you'll push that, and it'll start all of the different clocks you have. So those will be minutes, hours, 30 seconds, whatever the interval might be. And it'll allow you to time whatever you're trying to time. And earlier people thought, like, most people assume that this is what a pilot watch would be. And it did eventually become a pilot's watch, but it was originally invented for horse racing. So they basically timed the race, and it wasn't really the greatest design because you couldn't do, like, if you're on your phone and you want to time something, you can hit the lap button and it'll continue running the timer, but you can see how long it passed. You can like do multiple laps, like, so that basically was added when they added a flyback chronograph, which basically you push this main pusher again, and it'll continue running instead of stopping, because this one normally will start, stop, and this one will put it back to 12 to like reset the chronograph. So the flyback basically allows you to continue running, but just snap it back to the 12 without stopping the whole functionality, and allowing you to time multiple horse races or multiple laps of a horse race, or now no one really does that, but anything else you want to time, because I don't know what else you really time besides horse racing, but yeah. And then one of my favorite complications is the minute repeater, and this is a very long history because it's not really used nowadays, so it's mostly an older complication because the functionality is not that helpful, but it's just a beautiful complication. So back when pocket watches and clocks and everything like that were very popular, originally clocks, you could sometimes have a chain or a rope that you could pull, and it would chime you the time at night, so you didn't have to go and light a candle and then stumble your way over and look at the clock and figure out what time it was. But that was not a great system because only rich people could have the chain to pull in their room. So eventually, still, you'd have to be rich to get this, but basically what they did was they moved it up a system to pocket watches where you could push a button and separate from the main system. So you would have your own mainspring in this system because it's actually detached from the normal system, so it has its own power. So by pushing a button, you would wind that new spring, and then that would then start the system to chime the time. So you could use this when you're lying in bed and just want to hear the time, you would hit the button, and you wouldn't have to fumble around with a candle. Basically how it works is there's some arms, these like geared arms, and as the day goes on, it starts to pull the gears, it'll pull the arms like this, and then once you push the lever, they'll start to go back, and depending on how far and how long it takes them to go back, it'll chime you a certain amount of hours, a certain quarter hour, and then eventually your minutes. So it'll do, it has two chimes, so it'll do like a a dong 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 for hours, and then for the quarter hour it'll be like dong dong dong, that sort of thing. And this system, it's kind of weird because nowadays you don't need that because you have your phone and have a clock on everything. So when you have lights, you don't really need to hear the time. But back then it was very important because, like, if you're in class or if you're in a meeting with your boss, you don't want to go like, oh, what time it is? Like, oh, I gotta go. This is boring. So you wouldn't do that. You would then have your minute repeater in your pocket, press the button, and you could feel the chimes or sometimes even hear them. So it allowed you to basically like figure out what time it was without disrespecting someone. And now they're one of the most complicated and difficult watch complications to build. So they're very rare to see. I actually built my first one this summer while I was at Renaissance. One of my coworkers brought one in. But they're very, very cool and very intricate. And then, so as I said before, with the positioning and how it differs and affects the watches, something that Abraham Louis Breguet basically invented was the tourbillon. And this is kind of a crazy system because it takes the balance wheel and it normally just, you'll see a one-axis tourbillon if you see one. A four-axis is technically the most accurate you can get because it'll rotate it on all positions, so you get the horizontal, the vertical, and the diagonal position, so it'll average all of them. But the one-axis will just average the vertical, so if you have like different angles of the vertical. But it was very important for pocket watches because they had so many issues with different positions. So what it would basically do is it would just spin the balance and escapement all together and do 26 rotations an hour. And by doing this, it basically doesn't have the escapement stay in one position for long enough for it to really be effective, so it averages out the effect of gravity on the watch, allowing it to run consistently well. They were clearly very expensive because that's a very difficult system to build, so they were very rare then too, and they were all, once again, a symbol of status, and you had a tourbillon. But now, like that, they're very rare as well too today, because they are so difficult to build. And you can see like Jacob & Co. puts like a four-axis tourbillon in there just for fun because they just do crazy things. But most companies you won't see a tourbillon because they are so rare and so difficult to build. And now also, like I said before, like the hairspring doesn't really need to be adjusted that often because it's so well manufactured. Like with the silicon, you can basically get down to a very accurate measurement. That there's very little irregularity, but there still is some. But this is not as necessary as before. But yeah.
And this is still within a watch because it looks like it would be several inches thick to rotate.
Yeah. So this is like a 3D model, but it's normally inside the watch, so it will basically just take the balance and just spin it around. But if you do have, like for example, the four-axis, if you're spinning on more than just horizontally, then it has to be a little bit thicker. But still, it's simple to fit in the watch. And then now, so Renaissance, as I said, I worked there over the summer. So I can't say everything that I did because I just signed an NDA, but I can say a decent amount. So, like I said, they're an independent watch company, so they get to do whatever they want. And as you can tell, they're not normal watches. They look very different from what you'd see if you go to the store or whatever. But basically, their goal is to make the easiest and most legible watch that you can make. So basically, as this minute hand moves around the watch, all of these subdials move with it. Synchronize to basically go with it. So like this will always, the hand will always stay perfectly vertical, and it makes a more legible watch. And they've also done more interesting things. Like for example, this is the Type 3 on the right, which if you've ever worked with metal, you don't really put a lot of oil or water in your things because it messes things up. But what they did is they basically just said, no, we're going to put everything in oil. And so there's oil in the dial, and then this whole module, which is their own system, which they basically put on top of an ETA movement, which is just a standard movement, actually owned by Swatch Group, so they actually sell ETA movements, but basically they put this on top of there and it locks into place with this pin and that pin, or those two pins right there, and it basically locks into place and connects to a gear on top, and as it rotates, like the ETA movement, as that moves and rotates, that will rotate with it. But they said, no, we're going to put it all in oil, and it's going to be more legible because the dial, instead of having a gap in between the dial and the crystal, it looks like they're basically connected and almost looks like a screen. So you have no sort of glare or any sort of effect by light. So it's technically a better system, but it's very complicated to make. Like we joked because there was this company called U-Boat, and they tried to make one, but there's always a bubble in the dial, and that's not great if you want to try and make a watch that's very legible. But basically, so what they do is, because there's no crown on this watch, you have to, the case back is the crown, so you turn the case back different ways, so the winding is going to the right and then to the left you can set it. You have to find some way to connect these two through oil. So what they did is they basically did another thing you don't do with watches, which is put magnets in them. Because, like I said, with the gravity, any sort of force that can affect the hairspring will make it run worse. So if you have magnetism, it's going to make the two pieces attach and not run well because it'll be attracted this way or it'll be pulled along its axis and it won't run well. So normally what you do is you demagnetize every watch that you work on. But they put magnets in the watch to make it run. So basically what they do is they have a system here and then inside here on the module, and they have, because there's a blocker between the module and the ETA movement, because the ETA movement can't handle the oil. So they have a ballast system that basically dictates if it's like two, so here's the thermometer, because there's oil and a lot of it, like you said with the temperature in the winter and the summer, this one, because there's so much of it, it matters a lot. So if it gets too cold, the watch will not run well because the oil will get like solid, not fully solid, it won't freeze, but it'll get close and it'll not allow things to move very freely. And if it's too hot, it'll be too thin and try and seep out. So they have to have a ballast system that adjusts for it and adjusts for the pressure. But then attached to that, they have another system that has the magnets on the ETA movement, and they have one here. So basically, once the two things lock in, and if you ever play with magnets, it's sometimes hard to make sure they lock in because if you move too fast, they like disconnect, and if they're not too close or if they're not too far, like it doesn't work. So you have to be very careful with this one setting it because you can't go too fast or else it won't actually connect. But they do the magnet system basically to just allow them to keep the oil but keep the same no crown because that's one of the key things. And then over here is the Type 2, which is the most complicated watch. And that one is very interesting because it kind of takes the whole like smartwatch thing, like, oh, I don't want to set my watch, I don't want to deal with it, and then puts it in a mechanical watch. Because if you see here and here, these are basically the two systems that they have. So this one is a sub-dial within the on the hour hand, which those are open right now, but normally those would be closed. There's little windows that open and close depending on how low the battery is, and it allows the solar panels to basically take in energy and charge the watch. And then right here are the two time zone indicators. So basically you'll connect it to your phone and then you'll be able to tell, you can set which time zone you want. So there's two different ones, and then you can turn the E-crown off, which is their system, that's what they call it. It's called the E-crown. And so you have two different time zones and it connects to your phone, and so it'll also go to bed because it has the ability to like know how long it hasn't been worn for. Because it has technology involved. Instead of just constantly running, like if you have a mechanical watch, you can't really stop it. It's just going to keep running and keep losing power. So in this case, they allow it to go to bed, and if you double tap it, it'll wake back up. And once you do that, it'll start to basically readjust itself because it'll tell from your phone that it's not the right time. And it will basically take the inputs from your phone and then change the mechanical movement and adjust it so it's running at the perfect time. takes a few seconds depending on like how far or how close it is to the actual time, because it can't just like jump the hour, so it has to go all around. But in the end, it will get you to the right time. And it's a crazy watch. It's very interesting and very cool to work on. But like I said, most things like this don't happen unless you have an independent watch company, because like the Swatch Group people aren't like, this is what people want. Because people don't necessarily want that. They want a watch that looks normal and everyone can be like, oh, that's a Rolex, I know that. But these are very interesting and very intricate. And people have to be willing to do these things. Yeah. And, no, not low, but, basically, like I was saying, people have to be willing to make new watches. So there used to be a photo over here, but this one used to be IWC's Eternal Calendar, which they released during Watches of Wonders last year. And so normally a perpetual calendar, basically what it does, it tells you the month, the day, the date, and the leap year, or whether it's a leap year or not. And it also sometimes tells you the moon phase, which is already a lot to tell you. But the reason it's called a perpetual calendar is because it's accurate for a really long time. And it's not normally that long. It's like, you're not gonna ever see it be inaccurate. You're not gonna be living by the time it's inaccurate. But this one, the Eternal Calendar, which they released this year, is the longest accuracy of a perpetual calendar, and its accuracy is 40 million years. And that one, it's way beyond what was the longest perpetual calendar before that. And if you're wondering what happened 40 million years ago, it's when India collided with continental Asia. So just for frame of reference, that's what 40 million years is. And then in the middle we have Vacheron Constantin. So La Cartier is one of the like sects of their company. So basically they make the most complicated watches for Vacheron Constantin. And this one is the most complicated watch in the world. And I've been wondering, it's a pocket watch, and it doesn't look that big. Also this is one side, that's the other side. It doesn't look that big, but I say pocket watch, it's not really a pocket watch because it is basically the size of this tape measure, a little bit thicker, and you can't really put that in your pocket. So it's more of just a clock, but it works very well and does a lot of cool things. It has 63 different complications. So right here, you can actually see that's a tourbillon. And then it has the Hebrew and the Chinese calendar, and it has all sorts of different complications. It has all the different stars. It's a fascinating watch. There's a lot of things that you don't really need. So La Cartier, the funny thing is you basically are invited to make your own watch through them. So the guy who made this one also made the previously most complicated watch with 53 complications. So he now owns the two most complicated watches in the world, which is kind of crazy to think about. But as you can see, like this is a very traditional company. So they're the longest running watch company in the world, Vacheron Constantin. And still they're making advancements and they're doing crazy things, even though they're meant to be a traditional watch company. Which I feel like in most industries, when people think traditional, they think, oh, they're gonna like make the same car every year, make the same belt every year, make the same thing. But in watches, everyone's always trying to advance. They're not just trying to make the same thing. So that's why I think watches are so special. And then over here we have the Bulgari watch, which is the OUT Finissimo Ultra. It's the new one, I forget the name, but basically it's the new thinnest watch in the world. It's 1.7 millimeters. The previous one was 1.75, so they barely beat them. But if you're ever wondering how difficult it would be to work on a watch, that one seems like the hardest thing to ever work on in your life, because it's taking something that's already thin and then making it 10x thinner. So it's probably terrifying to do. But like things like this, which is normally like, Bulgari is not really known for like being the leading company in watchmaking. They're more of like a jewelry brand. They do make some watches. And the OUT Finissimo is a very thin watch, and it's a very nice watch. But they're not really known for, like Vacheron Constantin, for making advancements. But even them, they're making advancements and things like that. Thank you.
But before we get to the question and answers, I just wanted to point out to everyone On your chair is an actual stock certificate from Waltham Watch Company. This is real, not a reproduction, and it's yours to take with you. They've already been cashed in, so the value is historical and artistic, but you're welcome to have that. To our right, there is a table. Will has a selection of merchandise for sale. Please examine that before you leave, because you put some effort into curating that. And across the hall is some refreshments and some water and Q&A for Will. Thank you again for coming.
Thank you.
Feel free to take a brochure if you'd like one.
I had a question. The thinnest watch.
Yes.
Wasn't that beat last year by the Constantine Charity? It's the thinnest watch now.
So, I'm pretty sure, I think they made the thinnest tourbillon. Is that what you think of?
No. Like, it's like 2 millimeters thinner than
Oh, is it?
it's supposed to be.
Oh,
That was a thin one.
because, I don't know, I could be wrong, I don't know.
If anyone's got the loose watches, we can
Oh, yeah.
collect those again.
Will, do you have a favorite watch?
Must be this one that he's got to put back together.
Everyone always asks me that, and I don't really know. I do love, because Black here, people basically just go in there and they are given basically a menu of complications and you get to pick whatever you want. So people have made some amazing watches. Like there's some that can tell you the tide and if it's low or high tide in the area from where you're from. And there's just some crazy things. So I love their watches. They're not very easy to get because they're all one of one. But there's one specific, there's a skeletonized minute that they make, which I think is a beautiful watch. Yeah.
So plug for Razans.
Watchmakers.
Watchmaker. Yeah, if you ever need a watch repaired, the watchmaker. So, new location.
Well, yeah, my question is, when's the next time you're coming into work?
I will let you know. Any other questions?
What do they typically run, like price-wise? Complicated ones.
Well, so it depends on the complication because like a minute pier, normally it's around like $200,000. And then, but if you want like a chronograph, it's like 20 to 30. If you want like a really nice one, but you can also get like a quartz version of that for a lot cheaper. So it really depends what you're looking for. But it also depends on the brand. Like if you go to like Audemars, you're gonna spend 10x more than if you were to go to like F. Bijon.
But it sounds like the value's in the watch itself and the works rather than just gold and jewels piled on top of it like a cardigan.
Yeah, so yeah, it's mostly the like actual complication itself and the time needed to make it, but also the name too. So like if you buy like a Daytona from Rolex, it's probably gonna be more expensive than if you were to buy like Tissot sells a chronograph. It's gonna be more expensive if you buy the Rolex one. So it's like partially the name, but you can get things for a little bit less.
What's your watch of choice to wear?
So I wear a Grand Seiko. It's a GMT. So there's 2 different time zones. Yeah.
Do you want to tell them what GMT is?
Yeah. So GMT is general mean time, which is basically the time in Greenwich. So everything's adjusted from there. So that's why we are like New York is -5. So it's all like you remember when like why we minus? It's because it's all adjusted from London or Greenwich. So that's what general mean time is, and it's a very important thing if you want to like adjust your watch correctly. So you want to be in the right time zone.